The first part of Java that we're going to study about is variables. They are the key to being able to store information.
That seems like a good place to start. If the computer couldn't remember anything, it'd be pretty useless.
Here's an example of some Java code. We'll decode all of this soon, so don't let it overwhelm you. For the first 5 stages of the book, you only have to be able to read code. You don't have to be able to write it. Before we try to write code, we really want to understand how the code works. So for now, your job is to be the machine. Just learn to run the code and tell what it does.
Be the machine.
Keywords are words the compiler understands. They have specific meanings and are used in very specific ways. In our example, all of the words colored red are keywords. The public class example tells the compiler that we're building something named example. It also means that the code must be in a file named example.java. The public static void main line tells the compiler that this is the code we want to run. For now, don't worry about the details of these parts. Just know that we have to have them and that all of the code we write goes between the curly brackets in the part labeled main. Later, we'll see why they're there. The int keywords are the first keywords we really need to understand, but we need a little background before we can do that. Anytime we want the computer to remember something, you store it in a variable. Every variable has 3 things. It has a name, and there are some very specific rules for how we make those names. It can hold exactly 1 value, and it has a memory location where that value is stored. The compiler.
Remember, the compiler is the software that is translating our source code into Java bytecode.
That's right. Thanks for the reminder. The compiler needs to know about our variables because it writes the code that allocates the memory for each variable. This means that we need to tell the compiler about each variable before we can use that variable. We call this declaring the variable. The instruction that declares a variable specifies the type of information that the variable will hold and the name of the variable followed by a semicolon. For example, if we want a variable named Henry to hold an integer, we declare that variable with the command int Henry.
In this video, all of the examples that we're going to use, the variables are going to have the type int, which means that they can hold an integer, a whole number. But variables can hold all sorts of different things. They can hold real numbers, they can hold characters, they can hold music, they can hold videos, they can hold all sorts of stuff. But we'll learn about that later. For now, int will be good enough.
In our example code, we can see declarations of 2 variables named x and y. Both variables are declared to hold integers.
Integers are just whole numbers. 42, 0, negative 100, anything that doesn't have a fractional part.
Int is a keyword that the compiler knows that means that we are declaring a variable that will hold an integer.
You know, some languages don't even require you to say what type it is or declare a variable. This seems like a pain in the neck.
Jijun, you're right. One of the things that varies between programming languages is how they handle types. Java is strongly typed, which means each variable's type has to be declared and can't change. While other languages take different strategies, this choice means that the Java compiler can catch mistakes that programmers make before they cause a problem. Things that are compile time errors in Java would be runtime errors in loosely typed languages. That lets us fix things earlier. When we are running our code, we use memory diagrams to show how the code is storing information. A memory diagram shows the state of memory with a box for each variable that is labeled with the variable's name. As we execute the code, we will write in that box the value that that variable is holding. Once we've declared a variable, we use instructions called assignment statements to put values into those variables. An assignment statement is always of the form variable name equals sign value semicolon. This is an assignment statement that stores the value 32 into the variable named x. We can show the effect of an assignment statement by writing the value that gets stored into that variable's box. So this assignment statement causes us to write 32 into x's box. When we read the equal sign in an assignment statement, we say, is assigned the value or gets the value. It's important that we don't read this assignment statement as x equals 32. That sounds like a comparison, which isn't what the instruction means at all. The instruction encodes an action of storing a value into a variable, so we need to read it as that action. X is assigned the value 32, or X gets the value 32. Assignment statements always look like this: a variable name, an equal sign, an expression, and a semicolon. Note that the things inside the triangle brackets get filled with appropriate details when we write the code. When an assignment statement runs, the computer calculates the value of the right-hand side of the statement.
We call that evaluating the expression.
Then that value is stored into the variable whose name is on the left-hand side of the equal sign. It's really important to notice the purpose of the two sides of the instruction are different. The variable name that is being stored into is always on the left, and the value that we want to store there is always on the right. We read this statement as y gets the value x plus 4. When it is executed, the computer first evaluates the value of the x plus 4 on the right-hand side. To do that, it gets the value out of x, the 32 we stored there in the previous statement, adds 4 to it, so the value of the right-hand side is 36. It stores that value into the variable y that is on the left-hand side of the assignment statement. When we execute this assignment statement, we store the 36 into y. Note that the computer doesn't remember any relationship between x and y. It just stores the 36 into y and forgets that it got that by adding 4 to x. In this video, we learned about variables. We learned that every variable has a name, a value, and a place in memory where that value is stored. We learned how to tell the compiler about variables by declaring them. And we learned how to store values into variables using assignment statements.